In the frozen depths of a Georgian winter, survival tasted like wood smoke. Not the sharp scent of a hearth fire, but something deeper. The slow, resinous bite of oak and fruitwood, creeping through sealed timber walls. Inside a small, darkened shed, a fire that never flamed turned crisis into security. Hanging from iron hooks in the shadows, a year's worth of meat transformed from perishable flesh into something that could endure. A ham, a side of bacon. Provisions that would outlast the coldest months, preserved not by vast quantities of expensive salt, but by smoke, time, and deliberate engineering. This was the Georgian smokehouse, a chamber built to defeat rot, insects, and rancidity simultaneously. Its genius lay not in complexity, but in understanding. How wood burns, how air moves, how chemistry becomes armor. The late autumn slaughter was an event of abundance and peril in equal measure. A single pig, raised through spring and summer, yielded over 100 pounds of meat in a single day. For a rural family, this was a windfall, months of protein and fat, the difference between subsistence and hunger. It was also a countdown. Without refrigeration, this wealth would spoil within days. Bacterial decay would begin almost immediately. Flies would lay eggs in exposed flesh. The fat would oxidize, turning rancid and inedible. Every pound lost to rot was a pound stolen from February, when snow buried the ground and nothing grew. Salt could preserve meat, but salt was a strategic resource, mined in distant regions, transported overland, sometimes taxed. A large sack represented real expense for a smallholder. When heavy salt curing required enormous quantities, the meat packed in salt or submerged in saturated brine for weeks. Much of that salt would then be discarded or fed to livestock. Even after curing, the meat had to be soaked for hours to draw the salt back out before it was edible, a process that dulled flavor and wasted time. The smokehouse offered a different logic. It began with a light cure, either a dry rub of salt or a brief soak in weak brine. This was not preservation itself, it was preparation. The salt drew out surface moisture through osmosis, firming the meat's texture and creating an environment less hospitable to immediate bacterial growth. It bought time, just enough for the smoke to do its work. This was engineering by constraint. Use a little salt now to enable a more efficient system later. Oh, the real preservation would come from wood, air, and patience. The smokehouse was a sealed chamber, purpose-built for a single function, to produce dense smoke without heat. Most were small structures, brick, stone, or tightly joined wood, detached from the main house and barn. This isolation was deliberate. A fire meant to smolder for days was a controlled risk, one that could not be allowed near living quarters or stored grain. The structure itself had to contain that risk while channeling its output with precision. The walls were built thick and fitted close. Doors were heavy, designed to seal tightly. Windows were rare or absent entirely. This wasn't a shed for storage, it was a controlled environment. Any unintended draft would disrupt the process, either raising the internal temperature or dissipating the smoke before it could do its work. Materials mattered. Brick and stone offered fire resistance and thermal stability, holding an even temperature inside. Wood was cheaper, more common on smaller farms, but demanded more careful fire management. The floor was typically dirt or stone, fireproof, easy to clean, and indifferent to ash. At the heart of the system was the smoldering fire. This was the critical distinction: cold smoking, not hot. The goal was smoke without significant heat. Internal temperatures rarely rose above 30 degrees Celsius. Higher temperatures would cook the meat, rendering it vulnerable to spoilage once cooled. The fire was not a blaze. It was a carefully tended mound of hardwood sawdust or chips, often placed in a shallow pit dug into the floor or in a metal brazier. Starved of oxygen, it smoldered. producing immense volumes of smoke with almost no flame. But the choice of wood was not arbitrary. Dense hardwoods, oak, hickory, apple, cherry, burned slowly and yielded clean, aromatic smoke rich in preservative compounds. Resinous softwoods like pine were strictly avoided. Their smoke carried tars that left a sooty, acrid residue and failed to preserve effectively. This was knowledge encoded through generations. Not all smoke is equal. The chemistry of the wood dictated the chemistry of preservation. The structure itself became the engine. Smoke, being warm, rises. A small intake vent near the base allowed just enough air to sustain the smolder. The meat hung from rafters or iron hooks high in the chamber, directly in the path of the rising current. As smoke ascended, it bathed every surface of the hanging cuts. A small but baffled vent or chimney at the roof's peak allowed the smoke to eventually escape, creating a gentle but constant draw. This pulled fresh smoke upward in a continuous cycle, over the meat and out. The baffle prevented rain entry and blocked strong winds from reversing the flow. No pumps, no fans, just convection, driven by the heat differential between the smoldering pit and the outside air. The smokehouse was a passive machine, relying entirely on the behavior of heat and air. The structure did the work. The fire, the vents, the height of the rafters, each element existed in deliberate relationship to the others. Remove one, and the system failed. The transformation began with the surface. After the initial light cure, meat was often hung briefly in open air to dry. This created the pellicle, a tacky, protein-rich layer where moisture had evaporated, but the flesh remained receptive. This surface was essential. Smoke compounds needed something to adhere to. A wet surface would not hold them. A completely dried surface would not absorb them. The pellicle was the threshold state, the necessary condition for preservation to begin. Once inside the smokehouse, the chemistry started slowly. Smoke is not uniform. It carries hundreds of compounds, but the critical ones are phenols and creosote, complex organic molecules produced when lignin in wood breaks down under low oxygen combustion. These compounds are naturally antimicrobial and antifungal. As they settled onto the pellicle, they killed bacteria and mold spores on contact. They did not penetrate deep into the meat. They did not need to. The surface was the battlefield. Control the surface and you control decay. Day by day, the coating built. The pellicle darkened from pink to amber to deep mahogany. The smoke compounds polymerized into a tough, resinous shell, physical armor against the outside world. Flies could not penetrate it to lay eggs. Airborne bacteria could not colonize it. This was not a chemical deterrent. It was a barrier, as real as the timber walls of the smokehouse itself. The same compounds that blocked microbes also blocked oxygen. Rancidity is oxidation, fat molecules breaking down as they react with air. The creosote layer sealed the fat beneath, starving the oxidation reaction. Months later, the fat would still be pale and clean-tasting, but not yellowed and acrid. This was the third enemy defeated, not through salt or cold, but through chemistry borrowed from burning wood. Time was the variable the system demanded. Cold smoking a large ham could take 3 weeks, smaller cuts, perhaps 1. The fire required checking twice daily, enough to confirm the smolder continued, not so much that the process was laborious. The work was in the waiting. The meat shrank as it lost moisture. It grew firm. The raw, fleshy smell gave way to the deep, aromatic signature of the smoke. This was not just preservation, it was transformation. The meat that emerged was a different substance than what entered. Denser, darker, stable. When the process concluded, the cuts were moved to a cool, dry larder. There they could hang for months, sometimes over a year. On a well-smoked ham in January was protein security, a hedge against crop failure, against late frosts, against the weeks when nothing could be hunted or gathered. The smokehouse made survival possible not by dramatic intervention, but by patient, reliable engineering. It turned October's abundance into February's provision. The flavor we recognize today as traditional country ham or English bacon is a direct inheritance of this process. That characteristic smoky depth, the firm texture, the slight tang from the cure, all consequences of the Georgian system. These were not accidental qualities. They were the byproducts of necessity, refined over generations into something both functional and desirable. The smokehouse did not just prevent rot, it created taste worth preserving. The Georgian smokehouse has largely vanished from the countryside. Industrial refrigeration, vacuum sealing, and chemical preservatives have replaced the smoldering fire and the weeks of patient waiting. But the logic that built those small timber chambers remains worth understanding. This was not primitive guesswork. It was sophisticated engineering, passive, elegant, and effective. The people who designed these systems understood wood chemistry before it had a name. They grasped airflow dynamics without equations. They controlled microbial growth without ever seeing a bacterium. They worked within severe constraints, expensive salt, no electricity, the relentless tick of decay, and built solutions that functioned reliably for centuries. The smokehouse exemplifies a particular kind of problem solving, working with natural processes rather than against them, using structure and patience instead of brute force. It turned chemistry into architecture, time into preservation, scarcity into security. What hung from those rafters was more than meat. It was proof that limitation, when met with understanding, becomes the foundation for resilience. These systems have not entirely disappeared. Small-scale producers still cold smoke using variations of the Georgian method, and the flavors they create remain benchmarks of quality. The principles endure because they were never about technology. They were about observation, refinement, and respect for the materials at hand. Next time, we will examine another forgotten system that kept communities alive against the odds. A different environment, a different challenge, the same stubborn ingenuity.